Now, for question number 1, what do you think the square root of 7 times the square root of 5 is?
35.
Exactly. Square root of 35. All right. Now, again, these are not done on the calculator. Okay. The calculator is used to help you break them down. All right. But the multiplication, very simple. All right. If the numbers are under the radicals, you can just multiply them. All right. If there is a number outside the radical, you multiply the numbers on the outside of the radicals and you multiply the numbers on the inside of the radicals. All right. So with that being said, everybody should be able to look at number 3 and say, no, not 55. Square root of 55. Come on. Right. Remember, we're trying to get you ready for high school. All right. Let's act like it now. Square root of 55 is correct. Simple as that. All right. Now, obviously, number 5, now that you're paying attention, you have a little bit of understanding. You should be able to tell me that number 5 is the square root of 30m.
So what is radical? What is that?
What?
Like, so that's square root of 30m. What about, what is radical?
Same thing.
So then how is radical wrong to say?
Who said it was wrong?
You did.
I did not.
You said no square root. No.
It's the same
Just
thing.
said that it should be back in the same.
He said 55.
Oh, okay.
All right, number 7. Again, same process. It's just the square root of
30x.
30x. All right.
You're just backtracking.
Now, for question number 9.
22.
Now, I want everybody to listen to me. 3, 7, and 2. Those are all prime numbers. So if you multiply prime numbers, you won't have to break them down. Listen to what I just said. If you multiply prime numbers, you won't ever have to break them down. So this, of course, is the square root of 42. Guys. Give me a second. All right. Sorry again, guys. Now we're back and rolling. Okay, so again, we said number 7 was square root of 30x. And then we came down here. I was trying to tell you that 3, 7, and 2 are prime. So if you multiply them together, you won't have to worry about breaking them down. So that is 42, square root of 42. You may have any questions or concerns with that. All right, so now here is a more effective way. I know some of you can look at that and just say, well, 3 times 12 is 36. The square root of 36 is just what? 6. All right. However, if the numbers are bigger, it's not always better to just multiply them together. What I want everybody to do is, all right, look at 12 and say 12 is what? 4 times 3. All right, now please, you really have to pay attention here so I can show you how to work with radicals. All right, it gets a little bit more complicated as we go down the page. So if you're not familiar with the basics, when I get down to the harder problems, you're not going to know how to do it. All right, there are options. You can just multiply 3 times 12. However, that's not what I recommend. All right, I recommend that there is a radical 3 and a radical 3. What's radical 3 times radical 3? Which is what? What's radical 9? 3. So anytime you multiply the same number under the radical, it becomes that number. So radical 3 times radical 3, instead of telling me that it is radical 9, you can just tell me it's what? It's 3. All right, now here's what I'm saying. If you can't be distracted. So I'm looking at this right here. Does everybody see a radical 3 and radical 3? What is that?
9.
Radical 9, and the square root of 9 is what? 3. And then what's the square root of 4? 3 times 2? 6. Okay, So some of you are like, well, can I just multiply it together? Yes, you can multiply it together. So let me show you what I mean. Please look up. If I said the square root of 11 times the square root of 44, I'd want you looking at that and say, well, obviously that's just 22. All right, you should be able to look at that and say that's just 22. Because I'm not doing 11 times 44 and getting 484. And then the square root of 484 is 22. Most people don't know that. All right, but most people do know that 44 is what? 11 times 4. And so what is the square root of 11 times the square root of 11 now? Everybody's not going to say square root of 121. You're just going to say the square root of 11 times square root of 11 is what? 11. That's what you're supposed to know. And then what's the square root of 4? 2. And there you have it. All right. That's how I knew it was 22. All right. So now that you've been kind of listening, as we go down, should be okay. So everybody's going to look at square root of 10 times square root of 10 and tell me that is what? Just 10. Come on now. Square root of 10 times square root of 10 is just what? 10. All right. So easy. Now let's say you're not listening. 10 times 10 is what? 100. Square root of 100 is what?
10.
Is it the same answer? Yeah, it's just the long way. All right. Now, please look up. Can anybody look at that and tell me square root of 18 times square root of 6 is obviously what? You are amazing. That's why I said if you listen continuously, you would be scary. It's exactly right. Simple, simple, simple. How did you know that? Tell them. Because square root of 18 is 6 times 3. Now, why am I breaking it down to 6 times 3? Because I'm finding a 6 here and a 6 here. Because there are 2 6s, that comes out as a what? 6. So that's why it's 6 radical 3. All right. Now, if I wanted to, could I say 6 times 18 is the square root of 108, which is the square root of what we said yesterday, 36 times 3. And then the square root of 36 is what? And then 6 radical 3. Are they the same answer? Yes, there's just a really quick way of doing it. All right. The quick way is to always look for the common factors in both numbers. All right. So 417. Come on, everybody look. Is there a common 2? Yes. So 6 is 2 times 3. Is there a common x? Yes. So what comes outside the radical? 2x. What stays home because he has no one to play with? 3. That is correct. You have to come out in pairs. You have to come out in groups of 2. All right. 3 does not have another 3. So he's got to stay home. All right. The 2 2s can come out and the x's can come out. All right. Here we go. Now, of course, everybody's going to look at number 19 and say, obviously, that is just 2 radical 21. Thank you very much. 2 radical 21. Now, remember, getting smarter means you try before I put up the answer. And then you can say, yeah, I understand what I'm doing. All right. If not, you need to think about it some more. All right. So everybody's going to put down the answer that they think for 21. Ashley, what's the answer to 21? It's just 15 radical 21. How simple is that? All right, you multiply the 2 numbers together and you multiply the 2 radicals together. And that's how hard it is. That's simple, simple. All right, so continue on. All right, now we have a problem here. Come on now, it's really simple, but it's as we go down, it's getting a little bit harder, a little bit harder, a little bit harder. All right, first, what's 3 times 2?
Six.
6. Now, do I really want to multiply 5 times 10? No, can you? Yeah, but it's just going to be harder. You're supposed to look at the 5 and 10 and say, what's common with 5 and 10? 5. So mathematically, what I'm doing is I'm changing the 10 to 5 times 2, and then there's this 5 and this 5, so that comes out as a what? That comes out as a 5. And what's left behind?
Two.
What's left behind? 2. Thank you. And so what's 6 times 5? 30, radical 2. 30, radical 2. All right, any issues with that? All right, now, because there is addition, we are now distributing. We're distributing a square root of 5. So write down what you think the answer is. All right, Reese, tell them. Plus what? Someone help her.
25.
Someone help him.
35.
Thank you. Who said that?
Me.
Good job. Square root of 10 plus 5. Square root of 10 plus 5. Anybody have any questions?
Why isn't this square root?
If I said, what's the square root of 5 times the square root of 5, what is that?
Oh, it's 5.
It is indeed 5.
So why
Shh.
wouldn't you add the square root?
Say it again.
Why wouldn't you add the square root? on top of it?
Why wouldn't I add the square root? Okay, so let's talk about this. Square root of 5 times the square root of 2. Those are not the same numbers. So I multiply them together and get the square root of 10. If I wanted to, I could say square root of 5 times the square root of 5 is the square root of 25. What's the square root of 25?
Oh, I know.
You with me? So what I'm trying to tell you is, I don't want you to look at it as square root of 5 times square root of 5 is square root of 25. I want you to know I'm always looking for groups of 2. There are 2 5s. Therefore, the 5 or the 2 5s comes out as a single 5. Thank you very much for that. I appreciate it. All right. Now, again, I'm going down to 27 now. All right, you should have a little bit of better understanding. Review number 25, and let's talk about 27. All right, give yourself a second, write down the answer, and then we'll listen to Josh, all right, and see if he's good. Write something down. Ten seconds. All right, let's go. Tell me. 2 radical 15 minus.
9.
Who taught you this? Wow, that's very good, man. I mean, it's really simple. It's really simple. Now, I feel like everybody can get this one. I just feel like that's the easy one. All right. The hard one is multiplying square root of 3 times 3 radical 3. Does everybody understand we're multiplying, correct? So if I say square root of 3 times square root of 3, you are going to tell me that's what? No, 3. You can say square root of 9. All right. And some of you, that might be easier. Just say square root of 9, because then you know square root of 9 is what? 3. But now I have an extra 3 out there. So what do I do with those 2 3s? Multiply them together. Come on, it's really not that hard. And now it's 2 radical 15 minus 9, because I can't combine a radical and a number. And what I really should be saying is I can't combine an irrational number with a rational number. 9 is considered rational. Radical 15 is considered irrational. Irrational just means it can't be written as a fraction. All right. So now one step harder. Now we have a binomial times a binomial. So we had to do the two smiley faces. All right, so come on, it's not hard. It's not just radical 3 times radical 3 and 5 times 3. That's not the answer. All right, so let's look. Everyone should be able to tell me what's radical 3 times radical 3. 3. You can say radical 9. Better to say 3. Now we're doing the smiley face. This guy right here is how much? No. No.
5 radical 3.
Thank you. Plus 5 radical 3. Now I'm doing the second smiley face. This guy way over here. What's that? Plus 3 radical 3. That's nice. And now these two things. What is that? 15. Come on, guys. Everybody okay with that so far? And now, of course, what's 3 plus 15? 18. 5 radical 3 plus 3 radical 3 plus 8 radical 3. Go.
Does it matter which side they're on?
You mean 8 radical 3 plus 15?
It's 18.
Yes, I don't care, but traditionally, the way I write it is the way you would see a solution. So the rational number and then the irrational number. But you're right, it doesn't matter. You don't get marked off for putting it in the wrong order. Okay, come on now. Radicals are a big part of entrance exams. All right. So here we go. Everybody's looking at 31. Give it a shot. All right, Eddie. What am I starting with?
Radical 5 times radical 5.
Which is?
5.
You're awesome so far.
And then -1 times radical 5.
Exactly.
Which is just -1 and -5.
Good.
And then we would do radical 5 times 3, which is then 3 radical 5.
Exactly. Thank you, sir. And then what?
And then you do -1 times 3, which is -3.
Yeah, if you remember back to our multiplying binomial times a binomial, this is easy. And now you just have to apply the rules. Very simple. And now your final step is just to combine terms. So what's the final answer? Go, I'll let you tell me.
2 plus 2 radical 5.
Very, very nice. Honestly, if you can do that, you're in fantastic shape for multiplying. All right.
How is the 5 not a radical?
Because radical 5 times radical 5 is what? Is 5. The same number multiplied under the radical is that number. Square root of 7 times square root of 7 is 7. Square root of 13 times square root of 13 is 13. It's a different way of thinking about numbers. That's why some of you, it's taking you a little longer. All right, that's why I gave you a whole bunch of problems yesterday. All right, here we go. Now let's knock out 33. Now, what's true about the middle terms here? Can anybody remember? They cancel out. So do I have to do anything with the middle terms? No. Those of you guys who know what I mean, this is -2 radical 5 and this is +2 radical 5, and they do what? Cancel out. That's it. So when you look at this, you should just see radical 5 times radical 5, which is what? 5. -2 times +2. -4. Final answer, 1. Good job, guys. Anybody? All right, here we go. What happens to the middle term? Cancels. Radical 10 times radical 10. 10. Thank you. What happens to the middle terms? They cancel. Do you agree they cancel? Some of you guys now, you sit there and I tell you, I know I'm loud, right? But it's just silly sitting there not knowing how to do something. All right, now I'm all the way down to number 35, and some of you, I'm not sure what you're doing. All right. Any questions with radical 10 times radical 10? I'm talking. You're with me, right?
Yeah.
All right. I'm just trying to make sure. I want you to ask me if you don't know something. Don't be frustrated. Everybody's okay with radical 10 times radical 10? All right. Again, what happens to the middle term? Now, the reason why it cancels is because they're exactly the same, except one is positive and one is negative. Does everybody agree with that?
Yes.
All right, now what's 5 times negative 5? Negative 25. There you have it. So my answer is negative 15. All right. All right, let's try another one. Now it's supposed to be a little bit harder because we throw in a variable, but is it really? No. Now tell me about this. What happens to the middle term again? They cancel. So do I have to worry about the middle term? So now come on. Radical x times radical x is? Now it's the same thing if I said, right. If I said square root of 13 times square root of 13, we should just say 13, right? Now you are not wrong, Luca, to say square root of x squared. That is not wrong. All right, it's just that's going to simplify down to x. Does that make sense now? So we have x. And then what's the last? Minus 9. That's how simple. That's how easy. All right, here we go. Let's look at 39. All right, so now 39, we're expanding, right? So let's review. If I said x plus 2 squared, look up, please, make sure you remember this. X squared, the middle term is always, come on, x times 2 times 2. That was the middle term. All right, because the middle term is exactly the same. All right, so let's just review. So this would be square root of 3 plus 2, and then square root of 3 plus 2. Now, again, what's square root of 3 times square root of 3? 3. Now, the first smiley face, that gives me what? No. First smiley face give 2 radical 3. Second smiley face gives me another. And that's why you multiply by 2, because those two will always be the same. And then what's 2 times 2? 4. Exactly. So now go ahead. Good for you now.
Why wasn't it radical 3?
Because radical 3 times radical 3 is 3. True.
Sure, but on the other ones we were doing like because it's never mind.
You sure?
Yeah.
Okay, what? Okay, so now we're combining the 3 and the 4, which makes 7 plus 4 radical 3. All right. Now, let's do it this way. Look up, please. Square root of 3 plus 2 squared. All right, so here's the pattern again for those of you guys who are good at it. What's square root of 3 squared? 3. This times this is what? And then times 2 plus 4 radical 3. And then what's 2 squared? And there's the same answer. Does everybody agree? All right, there's just a little pattern there for squaring a binomial. I don't care which one you do. Go.
When you're doing it, do you do 2 times 2 or 2 squared?
The end?
Yeah,
Well, it's the same, actually.
I know, but like for like next one, like 5. Is
Well,
it
what do you
5 times
think?
2 or
What do you
5 times
think?
2? That's weird.
Right, exactly. All right, it just so happens that 2 squared is the same as 2 times 2. All right, here we go. So now let's try to do the pattern. What is square root of y squared? Y. Everybody's got that down. Y. Now we multiply this times this, which is negative 5 radical y. And then you multiply that by 2, negative 10 radical y. And then plus 25. Very nice. Easy. All right, I like it. Yes. Okay, here we go. Now I'm going down. Now the other problems, I just put a couple extra practice problems for you. All right, these should be, go ahead. These should be a breeze. All right, now the reason why I did this was because I wanted you to see multiplication and addition can get mixed up easily. So everybody look at number 43. How many radical fives do I have all together? How many? 6. The answer is 6 radical 5. Remember, the number in front tells you how many of these you have. 2 radical 5 plus 2 radical 5 plus 2 radical 5 is 6 radical 5. All right. Now, can I do anything with the 3 radical 2? Can I do anything with that? No. Can I do anything with these two things?
Yes.
Yes, that's a total of how many? Right, so negative 3 radical 2 plus 6 radical 5. Everybody okay with that? All right, here we go. What is 47? Everybody makes a mistake on that one.
-5/6.
Wow, negative 5 radical 6. Don't forget there's a 1. $49. Yeah, let's do 49. 6, what? 3 radical 6 plus 5 radical 5. Right? 3 plus 2 today is 5. Be careful, you're adding, not multiplying. All right, come on, guys. Not bad. Here we go, next. Okay, so now I have a problem with 18. What perfect square is in 18? 9 times 2. What's the square root of 9? So there's a 3 already out there. So what does that become? Negative 9 radical 2. All right, sorry. I don't want to go too fast. Everybody look at 51 again. Make sure you get caught up. Everybody look at 51. It's what we did yesterday, so it shouldn't be a big deal. More practice. Who knows that? Anybody have any issues with that? So my final answer is what? Negative 8 radical 2. Negative 8 radical 2. Everybody okay with this? Okay. What can I do here? Break what one? 12. Thank you very much. I break 12 down. Well, what does it break down to? Which one is it? There you go. Perfect, Molly. That's exactly right. None of those are perfect squares though, right? Right, you're only looking for perfect squares. So there is a what? 12 is not a perfect square, but it has a perfect square in it. Someone help him. What is 4? That's right, 4 times 3. So everybody write down negative 3 radical 6 minus what? What is radical 12 the same as? Yes, exactly. All right, so someone tell me the final answer here. There you have it. Negative 3 radical 6 plus radical 3. Anybody have any issues with that? Anybody? All right, so let's knock out 55 and call it a day for me anyway. All right, so again, we have 8 and we have 18. We've done 8 enough. You should be good with that. 3 radical 2 plus, how do I break 2 radical 8 down? What is that going to become? 4 radical what? 2 minus 9 radical 2. Whoever said that, good job. Now, once again, if you're not sure, you can tell me. Anybody? So now my final answer is close. Forgot the negative.
Negative.
Right? No, don't be sorry. That's good. -2, radical 2. Anybody have any issues? All right. Now I like this worksheet because the odd is very similar to the what? Even. All right. So good job today. Sorry, I had a little technical difficulty, but here, listen. I'm listening. Shh, yes, all of it. You're learning to work hard. 50. All right, good job, guys. Good job. Thank you so much. Avery, I hope you're doing well, kiddo.
Okay, yeah.
All right. I'll see you soon. Are you come back tomorrow?
No, I'll probably be online for like another week or so.
All righty. Well, get some rest.
Yeah.
See ya, Avery.
Bye.